The dash is perhaps the most iconic take on a double jump in platformer games, sending the player in a burst of speed in 8 directions around the map. This allows them to reach new heights, to pull off saves, and to platform like never before. In this video, we will be going over not only how to implement the dash as seen, sending the player in a high-speed movement in that direction, but we're also going to implement a few visual tweaks that make our dash look clean and awesome. Hello everybody, and welcome back to the next video in our platformer series. Today we'll be talking about how to add a dash, as well as some visual effects that really just make our dash feel so much cooler. Today we're going to start off by making a few adjustments to our state machine. As I've been working on one of my main projects that uses the same state machine, and I was doing some debugging, I came across a few little things and I was like, we could make this better in the state machine. And it is going to require just like a few lines of code, and it's not going to dramatically change anything else, just in one or two little spots in our main player script. So basically, how we're going to change this is, instead of like changing states, we're basically going to make the change state function request a change of states, and then a later function in our update will actually change the state. So what we're going to do is we're going to add one more variable here called var next state without a capital T. And we're going to set it to null. And then we're going to come down to our player functions. If I can find where our change state is. There it is. Perfect. So in our player functions and our change state, we're going to make this much simpler. We're just going to say, and then we're going to switch this to target state, because next state is now a variable we need. And we're going to say if target state, so if target state exists, then we're going to basically just assign our next state to equal target state. And then we're going to add a new function called handle state change. And all this is going to do is it's going to check to see if we've requested a change of state, and if so, change it. So we're going to say if our next state is not equal to null. So first off, have we requested a state? And then we're going to say if the current state is not equal to next state. So we have requested a state and we haven't transitioned yet. We're going to say our previous state equals our current state. And then we're going to exit our current state. So current state dot exit state. And then we're going to set our current state to null. Then we're going to set current state to next state. Now technically we could kind of just set current state to next state, but I like nulling it just to like clear everything out of that state. And then we're going to enter the new state. Current state, enter state. And then we're going to set next state to equal null. And then in our physics process up here, after move and slide at the very end, we're going to handle our state changes. So after everything's been processed, we'll handle that state change and we'll go on to the next state. And that's all the changes we're going to make to our state machine. So with that, we can get straight into the dash. So the dash is going to be composed of a few things. So the graphics effects for the dash are composed of the particle system from Godot, a little bit of scaling of our image, and then we're actually going to bring in a shader to add some distortion around the character as soon as they dash, and that'll add some cool effects. So let's go up to all of our variables, and with our facing, we're going to add our variables right here. So we're going to say var dashes equals 0, and then our variable, our dash direction, is going to be a vector 2 because we want 8 directional dashing. And then down here, we're going to say squish x equals 1.0, squish y also equals 1.0, and then squish step equals 1.0. Actually, we're going to make that 0.02. And that needs to be squish step. So this will be useful in our squish effect, but it would also be useful in a lot of other places in our dash. And then now we need to go up to our constants and add in some dash constants. So right here I'm going to say player variables. Right here I'm going to say constant max dashes is equal to 1. Constant, let me get my cursor out of the way. Our dash speed is going to be 300. Our dash acceleration is going to equal 4. Our dash time 0.15. So this dash is time based, not necessarily distance based. And then dash buffer time is 0.075. And this is going to be very important in a second. Alrighty, so with that, now we need to go into our inputs. Right here, so we're going to go project, settings, input map, and we're going to add a new input called dash. And our dash is going to be our X key. And then we're going to say variable key dash is equal to false. Go down to our get inputs. And we're going to say key dash is equal to input dot is action just pressed. Is action just pressed, and then dash. So that all looks good. And then we're going to come down to right above our flip H function, and we're going to add one more function called update squish. So we're going to say sprite.scale.x is equal to our squish x, and same thing on the y. Scale.y is equal to squish y. And now we're going to say if squish x is not equal to 1.0, so if we're not at normal size, then we're going to say squish x is equal to move towards, and then we want to move our squish x value to 1 at a rate of squish step. Oh, let's move toward single. I was like, why is it not liking that? And then we're actually going to do this. We're actually going to throw it out on one line. In Godot, you can throw it on one line as long as you still have that semicolon. And then we do the same thing, but just switch everything to our y values, like that. And so now if we ever call update squish, or if we ever call like a set squish, which we're going to make that function right now, then it'll update our squish automatically and just kind of slowly move the player back to or quickly, but move the player back to their normal scale. And we're just going to set some default variables in here. So squish x is like the desired squish x. Squish y is also going to be a float, and it's going to be equal 1.0. And then step float, which is going to be equal to our squish step by default. And then here we're going to write squish x is equal to underscore squish x, and we're going to say if underscore squish x is not equal to 0. And I say else 1.0. So this is like Godot's version of a ternary operator, which means we're kind of checking multiple conditions. We're saying if squish x is not equal to 0, then set squish x to the value we put in. But if it is set to 0, then keep it at 1 where it should be. And then down here, we're going to set squish step to equal step. And then we're also going to say if step is not equal to 0, else squish step. So obviously we don't want to set the scale to 0 because then the image disappears, and we don't want to permanently like scale down. We want the player to be able to return to their actual scale. So then the squish step function, or the update squish, we'll just put back up in our update, our physics process right here. And we can do this at the end of the frame. So just right here, we'll do update squish. And we'll say update squish. Perfect. So now if we change that, that system is all in place. Okay, so now we're going to come back here. I'm going to collapse all of this. We're going to add a new node 2D. And I'm going to call this graphics effects. Because we're going to have, we might be adding multiple effects, or you might add multiple effects to your platformer game. And so we are going to just kind of put all of these in like a folder by using a node 2D. So graphics effects, which is spelled wrong. We'll fix that in a second. Then we add dash. And then we're going to add CPU particle 2D and call this dash trail. Graphics, there we go. I can spell like a champ. So then if you haven't used Godot's particle system yet, it's fun. There's a lot of customization that you can do with it. And so like right now it's on emitting, the amount is how many particles it emits. So we're going to put this down to 4. And then there are a whole bunch of settings, like a ton. And so you kind of just have to do it on your own. So like ours is going to be a one-shot with the trail, but for now we're going to just keep it on emitting so we can see what it looks like. The only adjustments we're going to make is we're going to set speed scale to 3. The rest of these are going to stay the same. And you can like kind of read through like what each one does and whatnot. So speed scale is just how fast they're running. Next up, we're going to go to drawing. And we're going to do a texture. And so what we're going to do is we're actually going to drag in our character base. And that's going to not look good at all. So we're going to click on it, come down here to, no, that's not where we want to go. We want to do a new atlas texture. Drag in the atlas, perfect, because we want the region. And we're going to do 0, 352, and then the width is 32 and 32. And so this should get just our dash character. It's not doing anything, it's not showing anything here. Interesting. Well, we'll keep going through the other settings and then hopefully that'll fix what's going on there. We are going to go into gravity and we're going to set this to 0. So we don't want there to be any gravity. We don't want the particles to go anywhere per se. We just want them to kind of just be in place behind the player as the player dashes. And then we're going to go down to color. And we're going to do color ramp, new gradient. We're going to click on it. And we're going to switch this to white. And this we're actually going to switch to alpha, clear. And so what this effect will do is this will essentially have the effect of our player kind of getting drawn behind us. Oh, that's why it's not. working. I know why it's not working. Silly me, I haven't dragged in our new character yet with our new sprite sheet, so that's why nothing's showing up, because we're trying to grab something that doesn't exist. Fun, fun, fun. So let me grab that real quick. So we go to our character, we go to our sprite. This is now 8 by 12. If we really quickly just reset the gravity, okay, so that's showing the particles. So that's okay, so it is working. I don't know why it's showing that instead of this image. So let's try resetting that. There we go, that looks much better. Okay, so now you can see kind of the player. It is kind of like flickering. So those are the particles. It is working now. Perfect. Okay. So we've got the squish. We've got the dash trail, which we won't see until we actually implement the dash. Next up, we're actually going to need to create a new scene. And this scene will be for our distortion effect. So we're going to put this in our player right here. So we're going to create new scene. And I'm going to call this scene dash distortion. And this is actually, I'm going to make this out of a user interface. Perfect. And then we're going to add 2 child modes. We're going to add a color rect, and we're going to add an animator. We're going to call this animator. Perfect. So what a color rect is it's just a color, a rectangle that's colored. But what we specifically want to do with it is we're going to go down to our material, and we're going to go to a new shader material, and then we're going to go down to the shader editor. So if you don't know what a shader is, shader, and this shader is going to be called distortion. So if you don't know what a shader is basically a specialized code in a shader language that just like does graphical effects on your GPU. And so this shader comes from GodotShaders.com. I'll link this in the description. You can get lots of shaders from Godot. So it's not this shader right here, but it's somebody down in the comments actually commented a shader that works extremely well for a canvas item. This one up here is actually for the screen, so it's based on like the screen. It's like screen texture. And it doesn't quite center where we need it to be, but this fix down here that Merzad commented works amazingly well. So we're going to copy this shader, and we're going to paste it right here. Perfect. And I'm going to get rid of all of this random white space because, nope, not that. That's important stuff. Because gross, too much white space. Alright, that looks good to me. And now we have shader parameters down here. I grabbed the wrong shader actually, now that I look at this. Silly old me. So this is not the right shader. That's a great shader. That was not the one I thought it was. This is the actual shader we have right here. So this, all this up here, that's the old shader that we just had. And this is another shader. I can't remember who did this, but it's also from Godot Shaders, but I couldn't find it again. I will find it and link it in the description. If not, it will be in the project file. This is one of those shaders that is free to use. So yeah, so like there's no issues with credit or anything like that. Okay, so that shader is now put in there. And those need to be, I think this needs to be updated. So let's reset that actually, and then we're going to load this shader back in. Distortion shader, shader parameters. Okay, all those parameters are in there. Perfect. So now what we're going to do is in our animator, we're going to add a new animation, and we're going to call it distort. And I wasn't even close to spelling that correct. duplicate. We want to manage animations. We want to call this distort. And so on this track right here, we are going to animate the shader properties. And we're actually going to animate the radius of the shader, and that's what's going to kind of add that effect. So if we go back to our color rect, and we go over here to our radius, and we go to 0, we're going to hit keyframe, and then we're going to make this 0.3 seconds, very, very quick. And at the end of our animation, we are going to step at every 0.3. We're going to set the radius to 0.4. Radius 0.4. Enter. Keyframe. Perfect. That's our animation. Now we're not going to see any of this here because there's no image behind this, but it does work. It is there. Don't worry. We'll see it once we implement it. The last thing we need to do for this distortion effect is we need to add in a script called dash distortion. Spelled it right. Let's go. And we're going to bring our animator in. And this is something that somebody taught me in the comments. If you hold Control and then drag in your node, it'll just like make the onReady statement for me. I had no idea that you could do that, and that is wonderful. So in our ready statement, we're going to say animator.play, and we want to play distort. And then down here we're going to say await animator.animation finished, and we're going to say animator.stop just so that it doesn't do anything else, and then QUEUE free, which is just get rid of this node. So we're literally just creating this node. It's going to do the effect, and then it's going to delete itself. Now you have to be careful with this right here. This just awaits any animation anytime this animator finishes. Now in our case, we have one animation distort, and so that's fine. But if you have a statement like this in like your player and like a slide state, anytime any animation is finished, it's going to call this and then keep following that code regardless of the state you are currently in. So this can cause some issues. If you have multiple animations, it's always best to use a signal animation finish, because then here you can get the animation name, and then you can check that like the correct animation has finished and then do something based on that rather than just any animation being finished. Alrighty, there we have it. There's our dash distortion. So we're going to close our graphics effects. We're going to go back into our state machine, and we're going to start working on our player state. So let's add in a new state called dash. Let's grab all of our basic functions, put those in our dash state. Save this into our player state machine. Set that to dash, and then set everything to pass for now. Okay, perfect. And then we're going to add two new timers. We're going to add one called dash timer. And we're going to add one more called dash buffer. And so we are going to input buffer the dash, and you'll see why in a second. We're going to code the dash without the dash buffer, and then we're going to add in the dash buffer, because I want you all to try coding it without a dash buffer and just seeing like how annoying it is to not have a dash buffer. It's honestly, it's not terrible. This needs to be one more up. It's honestly not terrible, but like it is. But like it is much harder to time dashing in the proper direction. You have to technically hit the direction key first, then hit the dash button. But with the dash buffer, you can kind of hit them around the same time, and it's very difficult to not dash in the right direction. So that's a quality of life feature we're going to give to our player. Alrighty, back to our player. We are going to add 2 more functions related to our dash. So coming all the way down to our movement functions. Lots and lots of functions. Okay, right here. We're going to add function handle dash. And this is going to be if dashes is less than max dashes. So we can dash. And then we're going to say if the dash key has been pressed, and then we're going to say if dash timer dot time left is less than or equal to 0. So we're not current. So we can dash, we want to dash, and we're not currently dashing. Then we say dash timer dot start. Actually, hold on. This is yeah. Okay. So dash timer dot start, and then we're gonna say dash buffer time. So we're gonna add in the buffer time, but we're also going to well, we can set this to 0 so you can see how difficult it is without any time. And we're going to await dash timer dot timeout, and we're going to add 1 to our dash count, and then we're going to request a state change to states.dash, and it may not like that because we haven't added dash in here yet, so let's do that. And I'm just going to get rid of that node so it's all consistent in here. Okay, so that'll handle our dash. Perfect. And now we're going to say get dash direction. And this is going to return a vector 2. And so we're going to say variable direction equals vector2.0. So this is just like a temporary variable that we're going to return. And we're going to say if not key left and not key right and not key up and not key down. So if the player is not hitting any directional key of any sorts, we're going to set our direction to be equal to a vector 2 of facing and 0, and in which case it's just gonna dash which way the player is facing, right or left. So and we're gonna say else, so there is an input. Then what we want to do is we're gonna say direction is equal to vector 2. This needs to be input dot get axis. So get axis gets like the difference between 2 input directions, and I'll explain that a little bit more in a second. So that's our x, and then this is our y. We're going to make it down and up. Okay, and then at the very end of all this, we have to return the direction. Perfect. So what this is saying is, if right is a value of, so pressing the key is a value of 1, not pressing it is a value of 0. Get axis is comparing left and right, because if we're pressing right and left, if we do right minus left, so 1 minus 1 equals 0, perfect. If we do right minus left, and we go going left, so 0 minus 1, we get -1, which is left. Or if we're just pressing right, we get 1 minus 0, which is 1 positive right. Same thing works for down and up. And so this will allow 8 directional dashing, and we get the direction by doing that. Alrighty. So now let's go into our dash state. And this is where we're gonna do some fun coding. So first, constant dash squish equals 0.25. So that's the squish effect. And then we're also going to have distortion effect equals preload. So we're going to preload a scene, our distortion effect, and you can just drag that scene right there and it'll put the path right there. So we're gonna load this scene so it's ready on demand. And now we're gonna add a whole bunch of stuff into right here. So we're gonna say player dot dash direction equals player dot get dash direction. So get the dash direction. Next, we're gonna say player dot dash ghost dot restart. So the dash ghost, we actually haven't brought that in yet, but that is our graphic effect for our particle system. So down here, dash trail. I called it dash ghost. Dash. We'll keep it consistent with what I have in my project. Dash ghost. And we can even switch that to dash ghost, which means we need to switch this to dash ghost. Ghosty ghost. So restart the dash trail particles. The player's velocity is going to equal player dot dash direction dot normalized. This is very important right here. Times player dot dash speed. So normalizing, so a vector is an x and a y component. Normalizing is essentially making a vector so that the length is always the radius of a circle. So for those of you who have taken trigonometry and you have like your unit circle, the radius is always 1 from the center to, the outline of the circle. The issue we can get is if we're dashing in like at 45 degrees, so up to the right, up to the left, down to the right, and down to the left, we're actually dashing at an x speed of 1 and a y speed of 1, which if we get the hypotenuse of that, it's actually going to be 1 root 2. So we dash faster in like those 45 degrees. We don't want to do that, so we normalize it so that if we go directly up, it's 1, directly right, it's 1, and if we go up and to the right, it returns a value of 1. So we dash the same speed in every direction. If you do like an RPG, so like not a platformer but another 2D game where you can move in 4 directions, this is very important to make sure you don't move too fast in your 45 degrees. Alrighty, now we're going to say player dot dash timer dot start player dot dash time. We're going to say player dot set squish. There's a lot of code that goes in here, and we're going to say absolute value, so absolute player dot dash direction dot y times dash squish, and then we're going to duplicate that, but it's x. So yes, the axes are flipped on purpose, y and x, because think about it, if we're dashing to the right, we want our like our player to be stretched lengthwise, so they're longer and shorter. And so we do that by getting the x speed and changing it into the y axis. So we need to flip the axis for this dash to get the right squish effect. If you want, flip this to be x and y and do it, and then keep this as y and x, and it looks way better when the axes are flipped. Alright, now we're going to create a temporary variable called distortion. And this is going to be distortion effect, and we're going to say dot instantiate. And so that's basically saying create an instance of that scene. Now once we've done that, we need to set a few variables for this. So distortion dot global position equals player dot global position. So there's 2 position variables every node has. Position, so without this, just position, is the position of that node relative to its parent. So like, which would be dash, then graphics effects, then player. Global position is the position within the current scene. So we need to set the current scene position to be wherever the player is within that scene, which is like our world. So like if we're over here, we need the distortion to be here. If we're here, we need the distortion to be here. Dash day, that's where we are. Perfect. Now what we're going to say is get tree dot root dot get node, call it world dot add child distortion. So what this is saying, we're saying get the scene tree. So the scene tree is like the list of every single scene that is currently active. So in this case, it's like getting the very, very root, the first node that ever gets started that runs the whole program. It's like a behind the scenes thing. Then we're getting the root of that, and then we're looking in there and we're getting the world node. So we're basically saying, hey, in the game, out of everything that's running, just get us the world node and then add distortion on top of the world node. The reason we want to do that is the distortion will affect everything that's underneath it in its render order. So by adding it to the world, it's going to be on top of the player, of the background, of the level. So everything essentially, even like the background stuff, will get distorted with the player. It just makes the effect look really cool when we do it that way, so we're going to keep it that way. Alrighty, and then we're going to say player.animator.play dash, and we haven't added the dash animation yet. We'll do that in a second. And we're going to say player.handle flip H, because we want to make sure our player is facing the right way based on the dash direction. Alrighty, that's a lot of code right there for just that. But we've still got a little bit more to do in this scene, and then we'll move on to creating that animation, and then everything should start to work. So we're going to say function handle dash end. So we're going to say if player dot dash timer dot time left is less than or equal to 0. We're going to stop the dash timer. And it's always best to just stop your dash timers, because I mean, like, it's on, they should be on one shot. Yes, we'll set that to one shot. We'll set that to one shot, but just in case, it's always good practice just to stop them. And then we're going to do player velocity times equals 0.5. So we're actually going to let the player carry a little bit of momentum out of their dash. This we should actually technically, we're actually going to change. We're going to say player dot dash momentum carry. We're going to go into our constants in our player, go down to our dash constants, put this in here, and we're going to set it equal to 0.5. And so if you don't want the player to carry any momentum, then you can set that to 0. If you want them to carry all the momentum, you can set it to 1. And then we're going to say player dot change state states dot fall. Alrighty. And our handle animations, we're going to say player dot animator dot play dash. Now this may be redundant because we actually have it here, but we'll leave it there for now. And we're going to call handle flip H again. Perfect. Alrighty, so now we go into update and we say handle dash end, and we say handle animations. There we go. Animations, yes. Because I can't spell, that's why you can't find it. Perfect. Alrighty, we need to go to our animator, and we need to add a new animation called dash. Hit OK. Open up our sprite. Go all the way to like the very end. Our wall jumps, our wall grab, our wall climb, our wall slide, and there's our dash. Add frame, create, perfect. Looping can be as long as you want because it's just one frame. And that's it. So now everything should be up and running. This code should all be ready to work. Now we just need to add the states that we want the player to be able to dash in. I like the player to basically be able to dash in the fall state, the jump state, the idle state, the run state. So all 4 of those states, we should add in the player dash. So we're going to come down here, say player.handle dash, and we're just going to go through all of these states and let the player do it. Player.handle dash, jump state, player.handle dash, and where's our run state? Player.handle dash. Now if we run, let's see if we have any errors. I'm sure we'll have several. Oh no, we don't. So we can run, we can jump, and now if we dash, we have errors. Perfect. Okay, so dash state animator. Yep, animator. I can't spell. That is the bane of my existence. So if we jump, okay, another error. Play, that is a lowercase p, not a capital P. I haven't been doing too much C# lately. Ah, there we go. Okay. So as you can see, we keep animating, and that's because the dash effect, and that's because we forgot to put this on one shot. Perfect. So now let's do that. So we're going to try to dash up, and we dash down, and we can't redash. Perfect. I know exactly what's going on here. So player.handle landing. So when we land, perfect. Set dashes equal to 0. So we can that resets our dash. And then we need to switch down, up, left, and right. We got these backwards. I always do that. Okay, so now we should be able to dash in the right direction. So if we jump, dash up, perfect. Okay, so now as you can see, we squish when we dash up and we get that cool trail effect, but our distortion is definitely off. It's nowhere near where it should be. So let's figure out what's going on with our distortion effect. My guess is it's probably something to do with the shader properties. So let's go to our dash distortion, color rect, our shader. Okay, what do we have here? I just want to make sure all these properties are the same as kind of what I have. So this I have to 0.5, radius is 0. I have this to 0.01, and this to 0.2. Perfect, 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 perfect. And then the other thing that we probably need to do here is dash distortion. We need to center this color rect on here. So we're going to turn on our grid. We're going to do snapping 1 pixel by 1 pixel. Perfect. We need to center this, and then we're going to make it much bigger than this. So we need it to be 96 over here. And I'm going to drag this up to 96 as well. And then these ones need to go down to 96 and 96. So 96, 96. Yeah. So now let's see if that centers it back on our player. Ah, there we go. Perfect. And it also makes it bigger. So now you can see that shockwave. So like if I do it right up against here, you can see that distortion effect, and then you can see like the ghost trail behind the player. And so you can change this too. So like if we want there to be less of a ghost trail, we come down to here and we switch it to 2, and now we should have less of a ghost trail behind the player. So let's go where we can see more. Yeah, see, now there's only like 2 ghosts behind the player. I like 4. You can do it differently. Some people do their dash based on distance instead of time, so it just tracks, you know, the distance from where you started the dash to where you end the dash. And then every, 15 pixels or so, they draw a ghost, and the ghost is just like a new scene, kind of like this. You can do it that way. That's totally fine. I just like doing it this way, just because I like the particle effect. So now the last thing I want you all to do is our dash buffer in our player. We coded it in, set this to 0. And then if you go in, try dashing and hitting the direction at the same time. It's like actually quite difficult to get it right. Sometimes, you know, like you don't get it quite right. And it's just, yeah, it's just, it feels weird. It does feel weird. So adding in a little bit of a dash buffer is just a nice little cherry on top. Okay, there's one more effect that we can add to our code. This one you may or may not like. If you like it, awesome. If you don't like it, you obviously don't have to include it. But what we're going to do is we're actually going to add a little bit of a pause in all of the game before the player dashes. So we're essentially going to freeze the game for a split second, allowing the player to then like kind of dash. Like it won't read the player's input or anything like that, but it will be just like a cool little effect. So in our dash state, we're going to do os.delay millisecond player.dash delay effect. Now we haven't defined this yet, so let's go define that in our player. And I like this to be 30. So this is just going to add like a split second freeze right before a player dashes. So if we jump and then dash, jump, dash, you can make it like much more noticeable by increasing it. So like if we set this to like 200, it's going to freeze like a lot before we dash. So ready? Yeah, see that? So like that's obviously like way too much. So I like 30. It's very subtle. So yeah. Anyways, there we have it. There you have a dash where your player can go in 8 directions. The dash ends. Your player can, you can jump, dash into this wall, then grab it, just like you can in a lot of big games. You can from here you can jump. Oh, we haven't added we haven't added dashing out of our wall jump, so we need to go do that. So like idle state, let's copy this. So we want the player to be able to dash in a wall jump state. And so this will let the player dash before we, reach that peak of the wall jump. So we jump, climb, jump off, dash. Yep, see how we can dash right there, or we can immediately dash out. There we go. Perfect. So there you have it. Well, I hope you all enjoyed this video. If you are watching this and you've seen multiple videos and you're not subscribed, please consider subscribing. It's totally free for you. We're trying to hit 500 subscribers by the end of 2024. We're so close, so please do so, and I'll see you in the next video where we handle ledge grab mechanics.